So today the ds-incubator is again about testing our code. The series so far has had only one session, and I expect it to have today's and maybe 3 or 4 more at least. We have covered testing before, but we did it very briefly and in a very compact way. This time, because we are on a series, I think it's worth to kind of adjust the speed of the meetups to the interest and the experiences that people have with testing. So there is opportunities to ask questions. So in that, on one hand, I kind of apologize if you feel that this is moving a little slow. But then on the other hand, I know that I will be probably covering some details that are not even captured by the book that I'm following for this series. So as a reminder, it might sound odd, but I'm following a book about testing, about Shiny, and there's one chapter about testing that has generally a focus on testing Shiny applications, but really is a really good example of testing in general. So I'm kind of following that because also it's the latest writings from Hadley Wickham about testing. So I think that his experience is captured there better than in any other resource, including the book R Packages that includes chapter on testing, but I think it's not so good as the chapter on testing that lives in the book Mastering Shiny. So today we're going to be talking about mostly the mechanics. Last time we covered very theoretical ideas, and today we're going to be covering how to test files. How to work with test files and the basic workflow. That maps exactly with the name of the chapters on the book. This chapter called Testing Files and a chapter called Workflow. The sections in the chapter Testing. I'm very ineloquent today, sorry. The objectives are to basically do 3 things: understand the different levels in which tests are structured, from the level of a file, the level of a test, and the level of an expectation. We're going to be covering that in a moment. Also understand what is the basic workflow by using an example. We're going to build a function or copy paste a function called load file. And then we're going to be focusing on testing that function. Probably in the next chapter, we are going to be actually focusing on the R side of things and working more on the R on the code by doing some test-driven development. But today, the focus is not going to be the function, but it's going to be testing the function. Next time, we're going to be focusing on both the testing and the function, because we're going to be using this approach called test-driven development to actually develop the code that today we're going to just copy-paste. And finally, if we have time, we're going to be talking about the 4 ways in which you can run tests, line by line, running the whole test. That is a call simply to a function that lives in the that package called test_dat. To run then all tests in a file by using the function test_file, which we usually do in a keyboard shortcut, and then to run all the test suite in a package that we do with the function test. So that's the overview of what we're going to be covering today. As a reminder of the requirements, there's not much. We are covering all the ground very slowly, and I'm going to even be adding some. I'm going to be using not only test that, but also use this, which is a package that helps you develop our packages and also has functions to add infrastructure that you need to be able to run tests in a very kind of fluid way. So I'm going to, as of today, there is no real background that you need. If you watched the previous meetup, then great. If you didn't, you should be able to kind of catch up. So let's explore a little bit. By the way, there is a section, so if you go to the repo that hosts these materials and this specific series about testing, you will see that now in the resources section, there is a URL to a Google Doc. So that is kind of what I'm reading on my left screen that you're not seeing on the shared screen with you. So if you want to come back to what I've I kind of explain, you can go there and you'll find the material. So basically, let's start with discussing a little bit the structure, the 3-level structure of tests. The one, like kind of the bigger level is the level of a file. Basically, there is a mapping between some code that lives in the folder R in a package and code that lives in a different folder that is in the folder tests. Inside that, there is another folder called test that, and inside that there is one file for each file in R. So if we have a file that is, say, called load.r, then we're gonna have a file in the test that folder called test-load.r. We're gonna see that in a moment. That is a convention. You can actually put any test anywhere, but if you do follow the convention, life is easier. And also this has some helpers that help you implement that without even remembering that convention. And I'm gonna show you that in a moment. So the higher level of testing is the level of the file. Then there is multiple files, each with multiple tests. But going kind of to more detail, inside a file you can have one or more what's called tests, and a test is simply a call to a function that is called test_that, and I'm going to show you that in a moment too. What is a test? And that's the tricky part. This I'm going to read directly from a quote from the book, because I think it's pretty eloquent and succinctly conveys the challenge of testing. A test should generally check a single property of a function, although it's hard to exactly describe what that means, what is a property of a function. But a general and good heuristic is that if you can easily describe what that test is or what that property is very succinctly in one sentence, then probably you are getting it quite right. And we're going to see that again in action in a moment. And finally, within each test, which again is equal to test_that, there is what we call expectations. And that is what you exactly expect the output of your function to be. So some functions return true, then you call your function and the output should be exactly true. If it's false, that test will fail. If it's true, that test will pass. And the art of testing is figuring out how to write tests that clearly define the expected behavior of your function without depending on incidental details that might change in the future. And that's quoted directly from the book. And why? Because if you are in your test, if you are testing things that are going to change for sure, because it's a low-level detail that doesn't really it's not exposed to the user, but it's mostly for the convenience of the developer, then you're going to be changing, your test will fail all the time. You're going to be having to to synchronize your code with your test all the time. You're going to kind of worry yourself, you're going to get tired, and you're going to start losing trust in your test. And every time that you get a failure in your test, you're going to ignore it. So the art is to get those tests to a point where they only fail when the one property that you're interested about is the one that is changing. If other details are changing that are not relevant to those properties, then those tests should pass. And that will give you a safety network over which you can work, do changes, and only notice the changes that broke something that you care about, because your users are depending on that. And your users could be you yourself, right? So if you build a package for yourself, if you build some code for yourself, you're interested in making sure that that code still does what you want it to do. So when you wear the hat of the developer, you write that code, but then you're going to be wearing the hat of the analyst, and you're going to be using that code. And at that point, you're a user, so you're the user of your own code, and you want it to behave in the way that you expected. So let's get now to looking at a little code. So for this, let me start showing you. So usually, because I use packages a lot, I usually start by creating a package with a function from the use this package that is called create package. But today I'm gonna start in a way that maybe resembles more closely the experience that you might have if you haven't used packages a lot. So basically, you start with a project, which is not a package, and I don't really care about a package. You just want to add some tests. Okay, so how do you actually? What's your next step, basically? So this is an example of that. So this is the project ds.testing, which has a GitHub repository. I'm gonna expand here the console, and as you can see in the files tab, it's very simple. It only has an RStudio project file and a README file, and also a gitignore file. But I mean, this doesn't look at it as anything special, right? It's not an R package or anything. So, but we want to add some code, and we want later to test that code. So we are going to be using the package use this because it has a bunch of convenient functions that are going to make our life easier. For example, they implement the conventions that test that knows about. For example, if I want to write a function called, say, load_file, I could put it inside a file, and I'm going to use exactly the example that Hadley uses in the book. I could use, I could stick that in a file called load. I would probably do it in a file called exactly load_file, but for some reason Hadley decided to call it load, so I'm going to call it load. So there is a convenient function in the use this package that is called useR. So if I say useR and I give it the name load, what this will do will create a file called load inside the R folder. So notice that I still don't have any R folder here. So as soon as I run that function, use this actually creates that R folder, and inside it creates a file called load.r, right? So it's empty here for now, but I'm going to copy paste the code that comes from the book. So I'm copying here from my other screen into here. So that is the code that Hadley wrote as an implementation of this function called load file. Basically takes two arguments, the name of a file, which usually includes an extension, something like test .csv or test or whatever. I mean, it can be called emptycars.csv or emptycars.tsv. And then a path, which is everything before the name of the file. So something like, /Mauro, /home/Mauro, that would be a path to a file stored in that directory. So this function is extracting the extension from the name. So if the name of the function is, say, test.csv, is gonna get that CSV component. So that extension, this is a TSV or a CSV file, is gonna be stored here in the extension. And then Hadley is using the function switch, which is a very nice alternative to if. Instead of doing if else all the time, you can use switch, particularly if what determines the different path through the logic of if is a string of text. So in this first line here, I got a string of text that is going to be either CSV, TSV, or something that this function doesn't know about. And then if it is CSV, then it's going to read the file using a function from the vroom package, which is similar to the function in readr called read_csv. So vroom is just an alternative to readr. Clever error in some ways. And it's going to be using the delimiter comma. And if it is a TSV, it is going to be using the delimiter tab. And if it is not a CSV or neither a TSV, then it's going to basically throw an informative error. So I'm using exactly the code that Hadley put in the book to reduce confusion, but this could also be replaced by some kind of call to stop or something like that. Validate is a function that comes from Shiny. So this function base is similar to stop, but clever in the context of Shiny applications. That's a detail that is not very relevant for the purposes of testing. I'm getting to very close to the mark where I should stop. So what I'm going to do now is I'm going to create the test file that is the sibling, right? That is the counterpart of this code. So this is our code, similar to any function that you usually write. So now if we want to create the file where we should be putting our tests, then what we do is we call use, lowercase actually, use test. In this case, I don't need to add a string of text here of any kind because I have opened the file load.r. So use this is aware of the context in RStudio. It knows that I have the active file is called load.r, so it's going to use that information under the hoods to create a new file called test-load.r inside the test directory. So if I now show you the folder tests, you see that there is this folder test that, and you see that there is this file called test-load.r. So that is now not an empty file because by default it comes with a kind of toy example of a test, but we are going to remove this and change it to our convenience. We are at the mark where I should stop talking. I don't know if there are going to be a lot of questions, so I am actually going to probably take 1 minute to begin by copy pasting the code, the test code, and show you how it works. So I'm going to steal you a couple of minutes from the questions. I wanted to do a live demo actually of writing that code, but there's not going to be time. So yeah, I'm going to just copy paste it for now. Let's see. So we get to move a little faster. So I'm going to remove this completely and I'm going to replace it with a code that comes from the book. Basically, the first argument to the function, so you create a test with the function test.that, and it has two arguments. The first argument is this one here, and the second argument is this one here. The first argument is just a description of that property that you want to test. In this case, the property that we want to test is that load file handles all input types, and the valid input types are CSV and DSV, and anything else should fail. And the second argument, which is this one here, is just a bunch of code, because it's a multi-line argument. We need to embrace it with the curly braces, right? If it was just one line, we don't need curly braces, but this is a chunk of code that has multiple lines, so we need it. And notice that this first part, where we create data, all we are doing is creating something over which we can test. That is what, normally if you wanted to test that, a CSV file is doing what you want it to do, you could probably, open Excel, add a bunch of, information in there, and then, save that file somewhere and then read it. Okay, when you write tests, you have to learn how to transform all those clickings into code. So what we are doing here in between lines 3 and 7, we are first starting with a data frame on R, then creating empty files, one to host a CSV file and another one to host a TSV file. And then we are writing that data frame as a CSV or as a TSV inside that file. So that replaces all the clicking that you would do if you wanted to do this through, say, Excel. And finally, we have what we call those expectations, right, that we discussed before. Let me see the comments. So this is the structure of the test. Okay, I'm going to pause here for questions. Maybe the one thing I would like to do actually is to run this. So the 4 things I could run these tests are as follows. I could run this line by line, right? I could run this line, and you see that that manifests in the console. If the test pass or fail, actually I haven't loaded the function load file. Actually, I'm going to stop here for questions because probably this deserves more time in the next session. So let's see what we have now. I see a comment, let me read it. Go ahead if you have any question, otherwise let me know please. Any question or comment right now? Nothing yet. Okay, and then I'm gonna use, until you interrupt me, CJ, you are my timekeeper. So if is that okay if I keep going, trying to cover as much as what I had planned for today, and if there is any question, like directly just interrupt me and ask. Is that okay?
Yeah.
Okay, cool. Yeah, because we didn't get to any useful part. So the 4 ways of running tests are, as I said before, line by line is one way, but also notice how I got this message saying that load file doesn't exist. And here is where I wanted to show one more thing about testing infrastructure that does need a package. So when you use a package, or when you use tests inside a package, there's a bunch of convenient shortcuts that you can use, and there's particularly a function from the DevTools package that is called load all that will make the source code of the files in R available to the tests. So the reason why I got this error here when I was running this particular line is because the tests don't know about the function load file. What you could do, or what you have to do in a testing environment, is to use that function load all, which will source every file in the R folder and make it available to the test. So the test will then know about load file. But I don't even know if load all is gonna work here because my project is still not an R package. It looks like an R package, but it is missing the one component that defines it as a package, which is a file called description. So let me first, because I'm curious, let me run this function to see if load all actually does work without a description file. And it doesn't. Actually, it reminds me that it is missing a description file. So let me add that piece of infrastructure that we need to convert this into an R package. For that, we have a function in the use package, which is called use description. So that file, that function will create that one file description, right, that defines this as an R package. But there is one more catch. And that's why I wanted to show you this on the meetup, because it's not kind of explained, or maybe you're gonna miss it in the book, or I don't know if it is there. As you can see, even although this is now a package formally, RStudio still thinks that this is the old project before we converted it to a package. There is some information in this file called ds-testing.rproj that tells RStudio if a project is a normal project or if a project is an R package. We have changed that to make it like an R package, but this hasn't yet been manifested in RStudio. What we need to do now is to reopen the project, which I can do by going to the icon here that has the name of the package and click on itself. So I'm going to basically close this project and reopen it again. And now you will see something interesting, which is that the tabs available to you are different than the ones that were available to you before. Now we have a tab that is new to us. It didn't exist before. It's this tab called build, which includes a bunch of things, including the function, for example, load all that I showed you before, which I can click to basically load all functions, and also includes the function, for example, test package. So now you realize that by adding the description file, by running that function use description, not just that description file was modified, but also the RStudio file, the rproj file, was modified to tell RStudio that this is indeed an R package. So with that, I could now that I have loaded all functions, as you see, right? I usually do it with a keyboard shortcut, Ctrl-Shift-L, that runs the function load all. So now all functions are available to me. So for example, if I started typing load_file, that function should exist. And as you can see, it belongs to the namespace of the package ds.testing, which is the project that we are using now. So now let's talk about, or let's demonstrate those 4 ways. Now that this is a package, now test that will work, and let's demonstrate the 4 ways in which we can run this test. So line by line, once again, I can run line 3, 4, 5, 6, 7. With that, I created some test data, and I created it in a temporary environment that will or a temporary directory that will disappear when the session ends, so it doesn't pollute my file system. And I'm going to run the expectations. First expectation, second expectation, and third expectation. The first expectation is testing that running this code, that running the function load file with the name test.csv and the path to wherever that CSV is stored is equal to the data frame. Jackson?
You got 1 minute till data herald. Right.
Perfect. So the other expectation that is quite important is expect error. Same thing. Some code goes in the first argument, and in the case of expect error, we match the error message that we expect. And that error message comes from here, right? This is the error message that someone could get, and that is the error message that we want to match. This went a little fast, and I only showed one way to run tests, which is interactively, line by line. The second way is to run the whole test, and I can do that just by running the entire chunk. That's the second way. As you can see, I got a test passed message. The third way is to call the function test file, which I linked to a keyboard shortcut, Control-T. So that runs all the tests in this file. In this case, it is just one test. And the fourth way is to run the entire test suite, which you can run from here, from test package. So if there's multiple test files, they will all run with that function call. So line by line is one way. Test by test is another way. File by file is another way. And all the tests in a package is the final way. So with that, I ran out of time. Is there any question now that we have, now that I have actually shown something useful?
I have a quick question.
Yes.
If it's possible, so like at first you said you will do it without creating a package, but then in the end you did kind of create the package. So can you use the test.dat package without actually like having this description file? Did you need the description for DevTools or for testing as well?
Yeah, that's a good question. Not very sure what exactly I said, but I mean, you can use functions in the test.dat package. For example, expect equal. You can say 1 is equal to 2 and I'm gonna get an error. It's not. If I say 1 is equal to 1, it will work. So you can use it in that context, but it's not all that useful. It's useful when what you want to do really is to run DevTools test, and you want all tests in a package to run. So for DevTools test to work, you do need a package, because the package is a convention, and that convention is used by DevTools test to know where to look for those tests and how to match them with the corresponding code in R. So the infrastructure of the package is crucial for the workflow that that for the natural workflow of testing. Although you can use them in isolation.
Test.dat also has functions that you can run, like this test load.r file individually, or like a directory of them. So it can work outside of the package. I've used that before, like outside of the package context.
Yeah. In a way,
but it's much more convenient to follow with everything, because then they all work together and everything's magical.
I totally agree. I think that working with test.dat outside the context of a package feels like trying to force a square peg in a round hole, basically. And you can use it, but you have to do all these gymnastics that are just it's just buying a lot of friction for yourself.
Okay, thanks.
All right, thank you very much. Sorry for I'm just moving slow because by design, I want to make sure that we are not skipping important steps. Thank you, and see you next time.